All right, welcome back to the deep dive. Today we're getting into something I think is absolutely critical, which is the world of machine safety controls. You've really pulled together really fascinating collection of information, really looking at how we modernize some of these legacy machines, bring them up to modern safety standards with some pretty serious upgrades. And really, our mission today is to break down these concepts, pull out the key takeaways, the things you absolutely need to know, and I think most importantly, really understand why this even matters, right? For anyone involved in workplaces, focused on safety and efficiency, and we're going to cover the whole spectrum here. We're talking everything from protecting against explosions in hazardous environments to the nitty-gritty of emergency stops, and even diving deep into safeguarding presses.
Yeah, absolutely. You know what really stood out to me going through this material is just how multi-layered machine safety has to be. It's not just a single fix. It's a system of protections, really.
Right. Okay. Well, why don't we dive right in then? Let's start with an area that's obviously incredibly important, hazardous locations. You provided some great details about how we create safety enclosures for what we call class div rated areas. And just for context for folks listening, these are places where a spark, an arc, could have catastrophic consequences. So we're talking about using things like low voltage safety switches. Often you see these with distinctive blue wiring, running those through IMC conduit to a safe zone, and then using things like safety barriers and relays, all housed in these NEMA 79 enclosures, and of course all of this tied back to OSHA 1910.307. So, I guess my first question is, when we're dealing with these potentially explosive environments, what are the absolute non-negotiables, or what are the must-understand principles, and how do each of these specific components actually help achieve that safe state?
Yeah, so I think what's really important to understand here is that the primary strategy in a hazardous location is to prevent that ignition source in the first place. Because you're right, even a tiny spark can have devastating consequences in the wrong environment. So these low voltage safety switches, they're designed to minimize the amount of energy that's even available, right? So it reduces the chance of that spark even happening. That blue wiring you often see that often indicates an intrinsically safe circuit, and you can think of it, it's like a tiny watch battery compared to a car battery. It's just limiting that current and voltage to levels that simply can't cause an ignition.
I see.
And then you mentioned IMC conduit, so that's intermediate metal conduit. It's a very heavy-duty pipe, really, and it acts as a physical barrier, right? It protects those wires from damage, and it also contains any potential arcing that might happen accidentally.
Gotcha. So containment and really limiting that initial risk is key here. And those NEMA 79 enclosures, what's their role in this?
Yeah, so these enclosures are specifically built to contain an explosion if it were to happen inside, but also prevent it from spreading to the outside environment. So imagine a very strong sealed box, really. They also stop any dust from getting in, which in some hazardous locations, that can actually be an ignition source in itself. And then the safety barriers and relays that we talked about, they act as kind of gatekeepers. They limit the amount of energy that can actually go into that hazardous area in the first place. So even if there's a fault, they make sure that energy stays below that dangerous level that could cause an ignition.
Okay, so it's really about controlling that flow of energy at every single stage.
Exactly.
Yeah.
And the important thing to remember is all of this is backed up by regulations like OSHA 1910.307, which really lays down the law for safe installation and use in these really risky environments.
Right. So it's not just good practice. It's law, right?
Yeah.
It's got to be done.
Exactly.
Okay, now let's shift gears a little bit and talk about a different kind of challenge. We have a lot of legacy machines out there, older machines that might not have very sophisticated braking systems. And, the idea of using a safety encoder, a zero-speed feedback system, is a really intriguing one. This sounds like it's constantly checking the machine's status, mechanically, and only allows access maybe by unlocking a safety door once everything has actually come to a complete stop. So how does this approach actually guarantee that safe stop, and what are the big advantages of using this kind of speed feedback?
Yeah, so if we think about the fundamental goal of safeguarding, it's really about managing when the operator can actually interact with potentially moving parts.
Right.
So on these older machines where they might not have, great brakes or any brakes at all, just turning the power off might not, mean everything stops instantly.
Right. It could still be coasting.
Exactly. Yeah. It could keep moving for a while, which is a real hazard if someone tries to get in there too soon. So a safety encoder, it's giving us this constant real-time information about how fast the machine is actually rotating. And only when the system can verify that the speed is actually zero does it release the lock on the door, and then someone can safely go in.
So it's not just, kind of assuming it should be stopped after a certain amount of time. It's actually verifying mechanically that has happened.
Yeah, yeah, exactly. So the real advantage here is we're shifting from a time-based assumption to an actual mechanical confirmation.
Hmm.
And that's a huge improvement, especially for these older machines.
It's active, right? It's not passive. It's actively confirming the state.
Yeah, exactly. And this is particularly important when you have a machine that might have a lot of inertia, maybe a long rundown time, where that unexpected movement could be a real issue. And obviously having that door interlock, that adds another layer of protection, right? It physically prevents access until it's safe.
Right. Okay, so moving on, you also talked about these space-saving vertical safety doors, and these are really interesting because they're specifically designed to prevent pinch points. And the way they work, they use this double-acting cylinder. It's actuated by two-hand controls, and it's got a PO check valve to really minimize any risk of it dropping due to gravity. And then on top of that, you can even add things like rod locks, proximity sensors, safety valves. So first of all, what makes these vertical doors so beneficial? And then what's the significance of each of those additional components?
Yeah, so the real benefit of these vertical doors is that they have a much smaller footprint compared to your traditional swinging doors.
Yeah.
And in a lot of industrial environments, space is at a premium. So
Yeah.
so having that ability to really save some space can be a huge advantage. And because they're moving up and down, they don't need as much clear floor space around them. And you mentioned the double acting cylinder that gives you controlled movement in both directions, and that PO check valve that's pilot operated. It's a valve that needs a pilot pressure signal to open.
Yeah.
So that means that if the hydraulic pressure is lost, the door can't just suddenly drop because of gravity.
Right. So that prevents a sudden, potentially dangerous descent if there's a power outage or some kind of system failure.
Yeah, precisely. And then the two-hand controls, they're there to make sure that the operator's hands are safely out of the way as that door is moving. Now, if we add in things like rod locks, those act as an extra mechanical brake. So they provide that holding force to keep the door securely in position, which is really important in some high-risk applications. The proximity sensors, they give you feedback on the door's exact position. So is it fully open? Is it fully closed? Is it somewhere in between?
Right.
And that information can then be fed into the overall safety control system. And then finally, those safety valves, they manage that air or hydraulic power going to the cylinder. So they make sure that the movement's controlled and that nothing's being overpressurized.
Right. So it's really about adding layers of control and redundancy to really bolster that safety barrier.
Exactly. Every additional component just adds another layer of robustness and reliability.
Okay, great. Now let's talk about a safety measure that I think a lot of people are familiar with: two-hand controls. And specifically, you mentioned the Allen Bradley Opti button system with the anti-tie down relay. This is a pretty classic setup, and it seems like what it does is it forces the operator to use both hands simultaneously to initiate a machine cycle. And what's interesting is that you can actually adjust how far apart those buttons are, how high up they are, using brackets or pedestals. It makes it pretty versatile.
That's right.
So why is that anti-tie down feature, why is that so absolutely crucial, and in what types of scenarios are these systems the most effective?
Yeah, so the anti-tie down feature, that's really the heart of making a two-hand control safe.
Okay.
And the main thing it does is it prevents an operator from bypassing the safety.
Right.
So it stops someone from maybe taping down one button and just repeatedly pressing the other, or even using one hand or some other body part to activate both at the same time. So both buttons have to be pressed, and they have to be held within a very specific time frame for that cycle to start. And if either button's released during the cycle, the machine should stop or it shouldn't start at all. So the real power here isn't just about using two hands. It's about preventing someone from from tricking the system.
Right.
And that's a really important distinction.
Yeah, it's not just the physical requirement of two hands, it's the intelligence built into the system to make sure that it's not being defeated.
Precisely.
Okay, so it really ties the operator's hands literally to the safe operation and make sure they can't be in that dangerous area.
Exactly. And these systems, they're most useful when you've got an operator who needs to put their hands into a potentially dangerous area of a machine, but it's for loading, unloading material. So having both hands on those controls, it inherently keeps them out of harm's way when that machine's running.
Right, right. And the adjustability, I guess that's not just about comfort, it's also about making sure that you can really dial it in so that it's impossible to kind of cheat the system, right?
Yeah, exactly. You don't want an operator to be able to kind of comfortably reach around or bypass the system. It needs to be set up in a way that they have to use it correctly.
Right, right. Makes sense. Okay. Now let's get into fluid power. And let's start with pneumatics, compressed air. And you mentioned that this is, a big source of stored energy, and that pneumatic safety is really all about monitoring and controlling that energy, using safety valves. And these valves can do some pretty sophisticated stuff. They can do things like dual monitoring of air switches for synchronized timing. They can provide safe exhaust, with or without a soft start. They can make sure that components return to a safe position, and even offer safe control and load holding. And you talked about integrating Ross controls valves specifically for energy isolation and lockout valves, and then combining those with air prep components, your filters and your regulators, to create this whole air entry setup that's really comprehensive and all in line with ISO 4414.2010. So I guess the first question is, what are the main dangers that we're dealing with when we're talking about pneumatics? And how do these specific functions of the valves actually mitigate those risks?
Right. So the big danger with pneumatics is that stored energy in the compressed air.
Sure.
If you have an unexpected release of that energy, it can lead to really sudden, powerful movement of cylinders or other parts of the pneumatic system, and that creates a real risk of impact or crushing, or even getting entangled in the equipment. So these safety valves, they give you that reliable way to manage that energy.
Okay.
And you mentioned dual monitoring of air switches.
Yeah.
That's really adding in a layer of redundancy. So it's making sure that the valve is in the state it's supposed to be in, based on the control signal it's receiving. So it's like a double check.
Right. It's a fail-safe, essentially, if one of the switches were to have a problem.
Yeah, precisely. And then the safe exhaust functions, they allow that compressed air to be released, but in a controlled way. So it prevents those sudden movements when the power's cut. Yeah. The soft start option, that's really interesting because it lets the pressure build up gradually, so it avoids those jerky initial movements that can be really dangerous.
Right.
Safe return, that makes sure that actuators move back to a default safe position if the power's lost. And then the safe control and load holding, that prevents any kind of unintended movement of anything that's being supported by the pneumatic cylinder.
Okay.
And when you integrate those Ross controls valves and those lockout valves with the air preparation, what you're doing is you're creating a complete safe pneumatic system. So you can isolate that air supply during maintenance, which is really important. That's a key part of ISO 4414.2010.
Right. So it's not just about stopping the air. It's about doing it in a controlled, safe manner that doesn't introduce other hazards.
Exactly. Yeah, it's all about managing that energy.
Right. Okay. Now let's switch to hydraulics, which is obviously another incredibly powerful energy source. And here we're talking about controlling pumps, motors, cylinders, all these moving parts, to prevent serious hazards like cutting, crushing, being hit by projectiles.
Yeah.
And you mentioned that Ross Controls has these hydraulic safety valves that can be configured in a few different ways: block and bleed exhaust, block and hold stop, block and return, or even block and reduce speed, or dual block and stop. And all this is guided by ISO 4413.2010. So what are the unique safety challenges, I guess, that hydraulics present, and how do these different valve configurations, how do they address those specific challenges? Yeah, so with hydraulics, the big challenge, the thing that makes it really different from pneumatics is that we're dealing with much, much higher pressures. So the forces that a hydraulic system can generate are just, they're immense.
Right.
So if you have a sudden loss of pressure or some kind of failure in the control system, it can lead to really rapid and very powerful uncontrolled movements. So these different configurations of the hydraulic safety valves, they're really each designed to address a very specific type of risk. So a block and bleed or exhaust valve that isolates the hydraulic fluid and it safely releases the pressure. So that prevents any kind of unintended movement of the actuator.
Okay.
And that's really important for maintenance, before you do any work on that piece of equipment.
Right. Absolutely vital.
Yeah. A block and hold or stop valve that isolates the fluid and essentially locks the actuator in its current position. And that's really critical for preventing machinery from kind of drifting or falling unexpectedly.
Right.
A block and return valve that isolates the pressure, but it lets the fluid return back to the reservoir. And again, that's to prevent any kind of unwanted movement. And then finally, those block and reduce speed or dual block and stop valves, they provide an extra level of safety by either limiting the speed or providing that redundant blocking of the flow. And those are particularly important when you've got really high risk applications.
Okay.
And it's important to remember that all of this is guided by ISO 4413.2010. So that makes sure that these systems are being designed and implemented in line with recognized best practices.
Right.
Again, we're not just talking about good ideas here. We're talking about well-established standards. Okay, so let's talk about, I guess, what I think of as the first line of defense in many situations, which is emergency stop devices. You talked about both wired options, push buttons, boxes, integrated panel buttons, emergency rope pull devices, and these are all kind of in line with ISO 33850. And you really emphasized the importance of clear labeling and robust hardware so that you can very quickly activate these systems. So what are the key things to think about when it comes to placing these devices and make sure they're going to work reliably when they're needed?
Yeah, I think the absolute most important things to think about when you're putting in emergency stops is accessibility and visibility.
They need to be somewhere that anyone, any operator or anyone who's around that machine can get to it quickly and easily in an emergency. So that means you got to think about strategic points around the machine, within easy reach from any of the normal operating positions, but also any potential hazard zones. And the labeling is really critical. You need that clear, unambiguous labeling so that it's instantly recognizable. Even if someone's panicking, you don't want them fumbling around trying to work out what button to press.
Right. Right. Every second counts in those situations.
Yeah, absolutely. And when it comes to reliability, that comes down to a few things. Proper installation, using good quality, robust hardware that can handle that industrial environment, and then having that regular maintenance schedule and testing. You got to make sure these things are going to work when they need to. Now, the single or dual channel configuration you mentioned, that refers to the actual electrical circuitry within the e-stop system. And a dual channel system offers a higher level of safety because it can detect certain types of faults within the system itself, so it makes it more resilient.
Okay.
And complying with that ISO 12850 standard that makes sure that these devices meet those internationally recognized standards.
Right. So again, we're back to standards and making sure that we're meeting those best practices. Okay, so now for really large setups where running wires might be a real logistical nightmare or maybe just impossible, you mentioned these wireless emergency stop systems, and these are safety rated devices, and they use frequency hopping to kind of avoid interference, and they communicate back to a central control module. So what are the major advantages and I guess any potential drawbacks of going wireless for something as critical as an emergency stop?
Yeah, so the main advantage of a wireless e-stop is that flexibility.
Right.
When you've got a really large piece of equipment or maybe something like an AGV, an automated guided vehicle that's moving around a big facility running wires is just a nightmare. And that's where these wireless systems really come in. And that frequency hopping you mentioned, that's really key because it prevents interference. It's like the device is constantly changing radio channels very, very quickly. So it makes sure that communication is reliable, and importantly, these systems they're safety rated. So they're designed, they're tested, they're certified to meet the same requirements as those wired e-stops for stopping a machine in an emergency.
Okay. So they go through the same rigorous testing and meet the same standards. What are the downsides? What are the potential weaknesses of this approach?
Yeah, so the main things to think about are things like power. You know, the wireless transmitters need batteries, so you have to monitor that.
Right.
There's always the possibility, however remote, that there could be some kind of communication disruption.
Yeah.
Maybe some environmental factor that we didn't anticipate.
Right.
And then it's really important to make sure that the transmitter and receiver are securely paired so that you don't have any kind of accidental activation or deactivation.
Right. So security of the communication is paramount.
Yeah, exactly. And because they are wireless, regular testing and maintenance, that's even more important with these wireless systems.
Okay. Now let's talk about the grip enabling switch, which is often called a dead man switch. And this is a really interesting solution because it allows operators to bypass certain safety functions for specific tasks. Maybe they're making an adjustment, they're doing a quality check, but they need the machine running, at a slow jog or at a safe speed in continuous mode, and as soon as they release that switch, it triggers an e-stop. So what kinds of situations is this most appropriate for? And what are the inherent safety considerations that we need to keep in mind when we're using something like this?
Yeah, so this type of switch, it's really best suited for situations where an operator needs to be inside that potentially hazardous area of the machine,
Sure.
but it's running at a reduced speed, right? So
Yeah.
so it's for those specific tasks that can't be done with the machine completely stopped. So things like really precise setup or troubleshooting or making very small adjustments.
Oh.
And the key safety principle here is that the operator has to be actively holding that switch in a specific position.
Okay.
So usually it's like a firm grip, but not too tight.
Hmm.
And if they let go, or if they panic and squeeze it too hard, that breaks the circuit and the machine stops immediately.
Yeah. So demands this constant engagement, this conscious engagement from the operator.
Exactly. And that's where that dead man term comes from, right? It's making sure that if the operator becomes incapacitated for any reason, that machine will automatically shut down. But it's really important that these switches are only used for these very controlled tasks. And
Yeah.
the operators need to be properly trained on how to use them and what the risks are. They're definitely not meant for normal machine operation where you should always have those full safety Sherlocks in place.
Right. Okay, so let's move on to an area that's super critical, which is press safety. And you highlighted these Protect systems, light curtain systems, and these are designed for guarding the point of operation, but also the whole area around presses, whether it's manual or automated. And it sounds like they often involve some pretty significant upgrades to the control system itself, and they work together with traditional physical guards and safety laser scanners. And these upgrades can even include things like die blocks, power cutoffs, wedges. So how do light curtains and laser scanners, how do they make presses safer? And why is it so important to use them in conjunction with these other measures?
Right. So these light curtains and safety laser scanners, they're really sophisticated. They're electrosensitive protected devices. And they basically create this invisible safety barrier around the hazardous area. So if an operator or any part of their body breaks those light beams or enters that detection zone, it instantly sends a stop signal to the machine control system.
I see.
So you can kind of think of it as like an invisible tripwire.
Okay.
And they're really useful because they let operators get access to load and unload the press, but they still have that really fast safety response if something goes wrong.
Right. So it's a way to have access, but also have that immediate safety response if there's an issue.
Yeah, exactly. So they're really good for those kind of feeding and removing tasks, but
Yeah.
but they're most effective when they're used with those physical guards as well. And safety laser scanners, they give you a bit more flexibility, so you can use them to guard larger areas or maybe areas that are irregularly shaped.
Right.
And you can even set them up with warning zones that'll slow the machine down first, and then if the hazard gets closer, it trigger a full stop.
Okay.
And tying in those electronic systems with the physical measures like die blocks, power cutoffs, wedges, that's really important because it creates that redundancy, and it makes sure that the press can be locked out safely when you're doing maintenance or setup.
Right, right. Okay, so speaking of die blocks, you mentioned these power series die blocks. They're also known as RAM blocks, and these are used to physically support the upper die in a press, and they're there to prevent it from falling, which obviously could be a catastrophic crushing hazard. And these come in different sizes to handle different loads. You can adjust the height, and importantly, they include these safety interlock connections. And this all seems to be really important and in line with OSHA 1910.217. So why are these interlocks on die blocks so critical?
Yeah, so those safety interlocks, they essentially enforce the correct and safe use of those die blocks, because those blocks are typically used during maintenance or setup or when you're changing a die, and that's when the normal power and safety systems on the press might be disabled.
Right.
So these interlocks, they're usually hardwired into the press control system, and what they do is they stop the press from being turned on or from operating at all if that die block isn't properly in place and the interlock isn't engaged. So you can think of it as like a physical key.
Okay.
It's got to be in the right lock for that machine to run.
Gotcha. So it's that positive confirmation that the safety device is engaged, that it's working.
Yeah, exactly. So it makes absolutely sure that heavy die ram can't just suddenly fall and crush someone while they're working on the die. And without that interlock, there's a real danger that someone might, forget to take the die block out before they turn the press back on, or they might even try to run the press with the block still in place, which would be disastrous.
Right, right. So the interlock makes it impossible to make that mistake.
Yeah, it forces that proper use of the die block.
Right. It takes the human element out of the equation. Okay, now finally, you mentioned a couple of devices that aren't safety rated, but they still play a role in creating a safer work environment. And the first one was the CNC port spin window, and this is a device that automatically cleans coolant and chips away from the viewing area on CNC machines like milling machines and lathes. And what this does is it improves visibility for the operator, and it also reduces downtime. So how can something that's not directly a safety device actually contribute to a safer workplace?
Right. So yeah, improved visibility, it's not a primary safety control, but it can really help. By letting the operator actually see what's going on, they can spot any problems more easily.
Right.
They can see if a tool's wearing out or if it's broken, and that can prevent a lot of accidents. It also means they're not having to get as close to the moving parts to inspect the work. And then because you don't have to manually clean the viewing window as often, that reduces the operator's exposure to flying chips and coolant and things like that.
So it's really about being proactive and preventing those situations that could turn into a safety incident.